welcome back. My name is Rafael Escala. Today we will continue doing the explanation of the same data intensive application book. This is the 2026 edition, the early access. Okay. So to start, I want to do a small explanation of the latest video that we are talking about the difference of the operational analytical system. Okay. Take in mind that operational system is the part of the application layer that provides to the user to read and write the storage, right? And the analytical system only is created to be used by the business analyst or the data scientist. That is the purpose to be used, right? And it only have the read access because it's created using the operational system. The operational system also is called like online transaction processing or OLTP. And the analytical system is called like online analytical processing or OLAP, right? And take in mind that when we are working with analytical systems, we are working with data engineers. Data engineers have the responsibility to take care the part of the infrastructure and the pipelines to generate the data, and the analytical engineer is creating the goal is to create a data model to provide to the business analysts, and that's all. Okay, I want to talk about more about the data science later because there is some thing to explain about that. But okay, take in mind that in the analytical system, the storage that is created by the business analyst is called data warehouse. Okay, and the reason to have a data warehouse is not the business analyst not can't work, or it's very difficult to work with the OLTP storage or the operational system. It's because maybe you have to take in mind like an application developer. When you are working on the first time, when you are creating an application service or application service, you have to take in mind that you have to understand the business logic or the business decision to create an application, right? Because like a developer, you are working with multiple pages, multiple presentation layers, and when you are creating the entities of your database, is only to the goal of these entities is only to focus to create a small piece of entities to be useful for some pages. You don't want to create a single entity or a single storage or single entity actually to be accessible or to be reusable for many pages. Is the idea of when you are creating an application is trying to get to have the best performance in your app. So you don't want to create, you don't want to storage a single entity or single table that have a lot of data. You prefer to work with multiple tables that have isolated purpose for a single page of your application. And the idea is to be easier to be write or manipulate or handled by the application. So that is the reason when you are working with OLTP, right? And if you understand this explanation, you have to take in mind when you are working like business analyst, it will be very difficult to extract the data because you have to assume that there are multiple entities or multiple tables that have the data distributed. So you have to consume in these different entities to finally have a chart or finally have the data that it will be useful for you to take a decision. But because the data, the source of the data that is stored in the application is not useful for you, the data distributed is different. So we're talking about that is very difficult to combine these entities. It's not optimized to have to support expensive query, and is not a flexible schema, right? Actually, if you only take in mind that you are working with microservices, you have to take in mind that there could be multiple databases, and you have to extract of all them to finally have the final source. So only with that reason, there is no way to have the business analyst can work with the part of the storage of the OLTP. Okay, and so you prefer to work when you are suppose that you are a business analyst. You prefer to work with a different that storage that has to be isolated. That means that only you need to be access to only have the read only, right? Because you don't need to write. Actually, the source of truth lives in the part of the application when the user is trying to create something or update something on the storage, right? That is only the responsibility of the operational system. But in the case of the analytical, it's not necessary to write. Actually, when you write something, it's only to create a derived data, right? But created using the source of truth, right? That's it. And obviously, you have to. We are talking about the security of this storage because it's not necessary to be accessible for the application. It's only to be useful used by the analytics engineers. So that is a reason. And take in mind the query is in this layer of analytical is very, very expensive. And the idea is to not have impact with OLTP actually when to purpose of trying to access in this storage or database, if we take in mind that it will impact in the throughput or the bandwidth. So you don't want to affect the real user when you are trying to consume expensive queries. So that is the idea to be an isolated database, right? Okay, continue with this. There is another. There is alternative. Maybe if you want to create a database that supports OLTP, all LAP is when you are working with transactional process and analytical process. If there is an hybrid solution that is called HTAP, that is hybrid transaction analytic processing. And actually, the reason is when you in the application layer there is a service or purpose to create analytical services that take in mind that you don't need ETL to process the databases to create to support expensive query because you are trying to create maybe I don't know a page that you want to show what is the analytical for the customers, and obviously in this page had to be available to tracking or with some data range, date range, right, with a time frame filter. So in that case, for example, you would prefer to work with a storage that supports the analytical processing that is only to get data, right? So take in mind that this kind of databases support the part of the write and the read. And the read very, very with large volume of rows with low latency and with real-time changes. But nothing that this is the final storage that maybe you have to take in mind when you are taking a system design decision, because internally it's doing the same split storage actually. Only you have to understand the concept, because actually this kind of data storage is doing the same thing, the same approach, splitting the database in two versions, the OLTP and OLAP, right? And I have some example. We have the CockroachDB and TIDB. That's an alternative that maybe you can review, and the trade-off you want to implement, okay? But that is in summary. So how you can create a data warehouse. Okay, take in mind that there is a there is a process that is call it extract, transform, load, or call it ETL. Okay, when we are talking about the extract part is when you take in mind that the data warehouse, like I explained before, is working with the source of truth created by all transactional process, right? But also could be created using an external source that in this case could be generated by your CRM, that is an external service that you have to maybe pull it using API, or you can use other external product that connect with this storage external storage that you want. Actually, we have five tran or singer. Actually, they are provides a connection tool that you can use it to create your own ETL. Instead to create you have to create it manually, and in the advantage to work with this software is that you don't need to take care about maybe the updatings of this external API that you have to consume, right, to create your data warehouse. So take in mind that there are multiple alternatives to use this to generate this extraction. That if you want to create it manually, or you want to create an extra, you want to reuse some software alternatives. Okay, but take in mind that continue with that when you already extract all the data that you wanted, and there is a process of transform, because obviously we have the raw data. It could be multiple kind of data. It could be CSV or JSON files or rows of database, right? I don't know. It could the row of data could be a different extension, could have different extensions. So that need to be cleaned up, had to be a friendly schema to be to provide to the analyst engineer, right? Because analyst engineer will generate that modeling of the data and had to have a schema to support multiples, or had to be easier to easier to get to be consumed, right? And take in mind this process, it will be batch. Okay, it's an asynchronous process that will be generated periodically, right, within a schedule. And usually this transform will generate a relational model output to be consumed using SQL. That is an example, but that is the idea. And this responsibility actually will be generated by the data engineer, right? And the part of the load is because it will be sent for the business analyst, right? Or maybe the data scientist. But that isn't a question, because actually the data science prefer to not work with the transformed data, not like to the data science doesn't like to work with data transformed. The reason is because when the data science is working with machine learning or textual data, or maybe computer vision techniques, is not useful to work with SQL. So there is other alternative to be um, uh, used by the data science, and data warehouse is not for them. So we have to take a mind that when you are doing the extraction, you can create another kind of data, and it's called data lake. Data lake is a part when it's only just extracted data, and it could be included the raw data, the files, image, and video. And actually this is the data that it could be easier to be handled by data science, because data science could be generate patterns, could be use like I said before, is you can create vector of the data, vector matrix to generate this feature engineer, like this create a good performance to finally find opportunities statistical to finally create features for the company. So that is the idea. And actually, there is another good reason to 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 have this data lake is because you can create an reverse ETL. That is the when you are provide to the transactional process and another table to be prepared to be prepared consuming this data lake. Is imagine that you are working in an application services and you want to provide information for the user, and this information have to be processed by by the data engineer or OTL process, and this part in this layer on the data lake could be generated this data for the application layer, and finally we created the product feature, right? So that is when I call it reverse ETL, right? And how can do it? Well, the data scientist is working with SQL data model or with Python libraries that are talking about pandas or using the R libraries that R library that created to use statistical algorithms, right? So in summary, is that. And to continue with this explanation, maybe we can have two concepts that have to be clarified. That is the system of record and the derived data system. The system of record is the source of truth that is generated by the user. It's when the user creates something or writes something on the storage, the first thing or the latest thing or the final state of this user is live in the system of record. And the derived data system is only maybe could be generated, well, it's generated by the using the system of record that is the source of truth, but it could be maybe could have the compact information, compact data, or maybe aggregated data created using the created using the system of record, right? But that is in summary. The derived data system could be live in the application layer, but take in mind because not only just the derived data system could be an analytical system, because actually when you are working in an application, maybe you take in mind that you want to create a cache of some endpoint or some part of your application. That cache also is called a derived data system because it's not have the source of truth. It's only data that is storage, but it's not have the latest version. It's only maybe a snapshot, right? Right, that is created with the source of truth. So for that reason, the derived data system could be live on the application layer. Only take in mind that this derived data system should have a synchronization in some part of the application, because it need to be updated again, taking the system of record. Okay, take in mind of that. I want to complete this video talking about that databases are not inherently a system. The databases is only a tool, and the decision of which database it will fit in some data the same process depend of you and depend of their applications. So you have to take in mind that some maybe database could be fit in transactional process or could fit on the analytical system. You have the freedom to take that decision, but you have to take note that there are trade-offs. You have to know how to combine them, because actually the major or many databases assume that it was created to have to be your unique database. And maybe this is the part more complex, because if, for example, you're working with Postgres, maybe Postgres was created to take in mind that Postgres it will be everything, or it will be a single database in your application. But no, it's not. You have to take in mind that maybe you have worked with data distributed. So you have to support it. You have to support that this database had to be updated or synchronized with another service. So you have to take in mind that everything had to be fit and it have to be part of a whole data system processing, and not only just be not only just to be have a relationship with a single databases and the application that this database provides for you. So take a mind of that, take a high level decision about which databases you are have in your alternatives to take that decision, the final decision, and finally deep in the alternatives and in your application to finally have the final decision, right? Okay, so that's all for now. And the next video we will talking about the cloud versus the self-hosted. It will be very interesting. So thank you so much and see you the next time. Bye bye.